Hey there, you 12s. I can see another question for exercise 9H. Question 5. So here we go. Question 5 presents us with this problem. All right, so let's read the notation. They want you to find the derivative when x equals to 1. Okay, so when x equals 1, find the derivative at x equals 1. Okay, so essentially you sub 1 into the derivative equation, right? I'm just going to rub that out and make it look nicer. There we go. That's what you're doing. So first we need to find the derivative. Now we have the function, which is given here, f of x is equal to log e of square root of x squared plus 1. Okay, so our job is to find now the derivative. Now if you looked at my video for question 2e, which is now being uploaded, then you will understand what I mean by using double chain rule. So when I do this, in my mind, to find this answer, I like to explain it this way. So I would start off by saying, let y equal to f of x. And the reason why I do that is so that you're more familiar with the chain rule that I'm using. So if I do that, this now becomes y is equal to log e of the square root of x squared plus 1, okay? And this is where I would then say, we're trying to find delta y, delta x, right? So our goal is to find delta y, delta x, but we know using chain rule, I will then be able to do it if I did delta y, delta u. So introduce a third variable times delta u, delta x. Okay, so this third variable is going to be the key thing. What can I introduce to make my life easier? And this is what I mean. You see, this square root of x squared plus 1 is a problem. If I didn't have that, say I let u equal to square root of x squared plus 1, this makes my life easier because the equation now becomes y equals to log e of u instead. And that's much easier because I know in my rules that the delta y, delta x, the derivative of log e of any one single variable is equal to 1 over u. But that only works, oh sorry, that's not delta x, it should be delta u, sorry. This only worked because I had to simplify the problem. And I simplified it by introducing a third variable, which is over here, okay? So that's what chain rule is saying, that if you introduce a third variable, then you can find a portion or derivative of the portion of the equation, or the derivative for a part of the equation. Okay, so I've got delta y, delta u. I just need now delta u, delta x. Now, if you've seen my previous video, then you know you need to find now delta u, delta x, which is the derivative of this. And that to me is another chain rule problem. Okay, so hopefully at this point your chain rule is better. If it isn't, then watch my 2e and practice a few more question 2 to get a feel of the double chain rule. Because if you do it correctly, this u, I'm just going to do it over here actually, just to get you to understand. Oh, that's too many working solutions there. Let me just start again. This u is now currently equal to, now square root, the symbol square root is actually to the power of half. That's the same thing. When you write square root of a, that's the same thing as a to the power of half. Okay, so take that as a fact. Now, you've got x squared plus 1. And again, I would be using chain rule for this problem. So I imagine I'm starting afresh again and I need to introduce a third variable. This, again, is the problem. Because I totally know how to differentiate if I gave you x to the power of half. That was easy. It's not the half that's the issue. It's the fact that I have more than one variable. It's the x squared plus 1. Okay, so if you were able to find the derivative of this, then that's what I'm doing. So in my mind, I'm actually doing the derivative of something to the power of half. So in my mind, this is what I'm saying. Okay, I'm going to show you what I'm doing. Delta u, delta x, if I did it all in one step, right? I pretend as if this right here never existed. Right here. I pretend that never existed. In my mind, that's what I'm saying. And I think, okay, if I were to differentiate something to the power of half, what would that be? That's what I'm thinking. And I know to differentiate this, it would be half times whatever was in the bracket and then half minus 1. That's using the power rule, right? Now in the bracket, it's actually x squared plus 1. So that's that component. That's your delta, that's the derivative of the portion of it. But the only reason why I can simply just ignore this x squared plus 1 is because in my mind, I'm introducing another variable. I'm saying, let this new variable equal to x squared plus 1. So that means I do need to differentiate this part as well. So multiplying this to the derivative of x squared plus 1 is 2x. So then in my mind, I know this is what I'm doing. Okay, so if I were to do all of this in one step, this is what it looks like. So to simplify it now, half times the 2 will cancel out, and then you get x times x squared plus 1 to the power of half minus 1 is negative half. And this is the same thing as writing x times 1 over, because the negative, you can bring the power down, it becomes x squared plus 1 to the power of positive half. And then that's the same thing as writing x over x squared plus 1. And remember, to the power of half is the same thing as square root. So this right there is my delta u delta x. So that's what I mean by you do a double chain rule, but you're meant to be able to do it all in one step. So if you can do that all in one step and you understand what I'm saying, then now to answer the question, the derivative, remember delta y delta x was the goal, right? It is delta y delta u times delta u delta x. We have both. We've got 1 on u multiplied to x over root of x squared plus 1. Putting the u back, so u, we remember we introduced it over here. That's what u equals to. So 1 over u would now become 1 over the root of x squared plus 1 multiplied to x over the root of x squared plus 1. Hopefully your surds are okay. So at this point, you would know that when you multiply two surds that are exactly the same, the surds cancel out. It's like saying root 3 times root 3. That becomes root 9, but root of 9 is 3. So essentially it feels like you just remove the square root symbol. Okay? So I know that when I multiply these two together, I should get x over x squared plus 1. And that's my delta y delta x. But don't forget, I introduced the y variable, remember? So really, you should finish off your final answer as f dash of x is equal to x over x squared plus 1. Oh, look at all those steps there. So once you've done all that, remember the question was asking you to find for the derivative, find the derivative when x equals 1. So now I've got my derivative. So at x equals 1, then derivative of at x equals 1 is equal to 1 over 1 squared plus 1, which is 1 over 1 plus 1, which is 2. So this is what my answer should be. Okay? Now, just for those who are a bit curious on how I did the chain rule for this one, I'm just going to show it again. So remember, our answer was this. Okay, this is our answer. I'm going to show you the long method instead of the shortcut method, just so you can see it better. So u is equal to x squared plus 1 squared, right? If it helps you, I'll call this y just to prove my point. Okay, I'm going to call this y for now. If you were to differentiate this is what I would have done. So the proper way is you say, let u equal to x squared plus 1. That changes the problem, makes it easier, so that it becomes y is equal to u squared. True, because you replaced x squared plus 1 with the letter u. That means that to find the derivative is much easier now. Delta y delta u is just 2u. You got part of it. But because you introduced this new variable, you have to differentiate that as well. So delta u delta x will equal to derivative of x squared is 2x and derivative of 1 is 0. Now I've got delta u delta x. So when you want to find the derivative, remember the derivative was delta y delta x. Using chain rule, this tells me you can write it as delta y delta u multiplied to delta u delta x. True? I've got my 2x and I've got my 2u. Okay? Wait, is it u or was it half? What was it again? Oh, whoops, my bad. That was half. So this now changes the problem to Oh, this is half, and that's then half. Half minus 1 is negative half. Okay. So now I can do my solution here and say that delta y delta u is half times u to the power negative half, multiplied delta u delta x, which is 2x. And you can rewrite this as 1 over 2 multiplied to 1 over root of u times 2x, which combining them together is 2x over 2 times root of u, which is the same thing as writing the 2's cancel out. 2 divided by 2 cancels out to be 1. And so it becomes x over the square root of u. Now what's u? X squared plus 1. So this is your delta y delta x. Okay, so that's the long way showing the chain rule, how I would have done it, and I would have got the same answer. See, x over x root of x squared plus 1, same thing. Okay, this is actually showing how I introduced that third variable. The reason why students may find this tricky is because you've already done the chain rule. You called something u over here, so you got introduced the third variable. When you do it again, you got to use a different letter. So it may be a as an example. So I usually use a. So delta u delta x is what I want. If I need to introduce a third variable, I use a. So delta u delta a times delta a delta x. And that's what students find tricky because they're not familiar with that sort of notation. But that's essentially what you would do if you want to do it properly. Otherwise, this is how I probably would have done it in one go, and I would have got this answer, and then I would have just put them all together to find delta y delta x. So I would have just substituted this right here, this one here. I would have got this step, and I would have probably just jumped from that to that step there, and then I would have answered this question. Okay, hopefully that helps with the understanding. Pause anywhere you need, but this indicates to me that chain rule or double chain rule, it needs practice.